In this video, I'll be looking at the concept of an occupancy map with regard to robot navigation. And the basic idea is we break the environment up into a grid. So maybe we break the environment up into a grid of squares, maybe 1 centimeter by 1 centimeter. That's a fairly small size, small granularity of the grid there. And we call this grid an occupancy map. And the idea is we calculate, or we put in the probabilistic occupancy of that particular square is occupied or not occupied. So the value will be between 0 and 1, and it will be a probability that that particular cell is occupied. Just remembering that our sensors have errors associated with them. So even if our sensor doesn't detect something, well, there might still be something there, particularly if it's detected it from different positions, but it's not currently detecting it at the moment. Sensors may have errors not just associated with not detecting versus detecting, but also in the range that they detect these things at as well. And so the actual position of the walls, for example, that we're trying to detect, we might not know exactly where they are, particularly down to that centimeter or even better resolution, but we might have a very good idea where they are and what sort of contour that they actually follow. It also allows us to what we call age our sensor data. So this can help to remove those dynamic obstacles when a cat walks through, or a door that was open but now is closed, or something like that. It gives us a better picture of what the occupancy map currently looks like, not just what it looked like in the future. So the idea is that a lot of environments won't be completely static environments where nothing ever changes. Things change, that's life, and we want to be able to interact with our robots and not have them in a separate building all by themselves that we can't actually interact with and they can't do anything meaningful for us. So here's a diagrammatic view of this Bayesian probability grid. So we have a whole lot of squares there. This one's probably a lot coarser than the 1 centimeter grid that I talked about previously, and we see the darker squares there are closer to where we're quite sure that that particular grid square is occupied. There's obstacles there. Whereas the lighter squares there, we're more confident that that grid won't be occupied, and we can actually move into that grid if we do want to.